Hello, this is Dr. K. Welcome to Module 5 on the analysis model. This module is somewhat based on chapters 9 through 11 of Software Engineering, a Practitioner's Approach by Roger Pressman and Bruce Maxim. However, we're going to skip over some of the material there, and we're going to add a little bit of material also. We'll talk about what goes into an analysis model and the kinds of work products that you might create, especially the UML diagrams. In this video, we're going to look at a quick overview of the analysis model. We'll see where the analysis model fits into the software lifecycle, and we'll look at the different elements of the analysis model. According to Pressman, the analysis model should answer these questions. The first three are especially important. What objects does the system manipulate? What functions are performed? And what behaviors does the system exhibit? The other two questions, what interfaces are defined and what constraints are present, are also questions you should answer, but Pressman gives particular emphasis to the objects, functions, and behaviors that comprise a system. A good way to view the analysis model is as an intermediate step between the system description, which is what you obtain from requirements gathering, and the design model, which is what your developers will use as a guide for implementing the system. In that respect, you can also see the analysis model, which is a way of formalizing the requirements, as a bridge between the customers who have the requirements and the developers who are ultimately going to implement those requirements. Since the analysis model is the bridge between the customers and the developers, it's also something that should be understandable by both the customers and the developers. So it should reflect the requirements well enough so that the customers can understand it, and it should be formal enough so that the developers can start to see how they would design a system based on it. These are some analysis model rules of thumb. The first two, I think, are probably the most important. The first says that you should focus on the problem domain. That's the domain you're working in. For example, air traffic control, e-commerce, or online gaming. Don't pollute your model with unnecessary information that doesn't directly solve the problem at hand. And this is where the second item comes in. Remember that you're working in a high level of abstraction here. You're not looking for all the details of the solution yet. You want the big picture. The other rules of thumbs are each element should provide insight into information domain, function, and behavior of a system. That harkens back to that notion of objects, functions, and behavior that we talked about in a previous slide. Delay infrastructure non-functional models until design. That's really about the level of abstraction. Finally, minimize coupling throughout the system, provide value to all stakeholders, and keep the model as simple as possible. Well, those are always good modeling principles to follow. The analysis model is made up of four kinds of elements: scenario-based elements, flow-oriented elements, class-based elements, and behavioral elements. Not all of these elements will be implemented in every model. For example, if you're using an object-oriented language, the class-based elements are much more likely to be implemented than the flow-oriented elements. In the remaining videos of this module, we'll look in detail at each of these four kinds of elements. And if there's a particular diagram I think is important to understand, we'll spend a little more time on that. So let's get started. In the next video, we'll look at the scenario-based elements.